In this video, we are going to go over scientific notation. Now, scientific notation is a way to get very large numbers, like numbers in like not just the millions, but in like the billions or trillions or I don't know what's after that, gazillions. Numbers with lots of zeros, either really large or really, really small. Like if I were to measure the size of an atom, that might be like 0.00000000002 inches or something. So why do they call it scientific notation? Because like in science, especially when we're talking about like space or like I don't know, we're talking about like atoms and stuff like that. So you got like, look at that, atoms. When you're talking about very big things and very small things, you're like measuring large and small things, you end up having to talk about large numbers or very small numbers, and it really doesn't make sense to be writing these really long, tiny numbers and or these really large numbers constantly. So they use scientific notation to shorten things. Will you be using scientific notation in life? We'll see. Maybe you'll be a scientist. All right, let's get started. Scientific notation is a shorthand way of writing really large, or let's go big, smaller, and really small numbers, really big and really small. Very great and very tiny, I guess. Scientific notation is written as a product of two numbers. What's a product again? It is, it's the answer of a multiplication problem. And there's a little multiplication x. The first number must be between 0 and, not 0, sorry. It must be between 1 and 10. And the second number must be a power of 10. So examples of that would be like 10 to the first power, or 10 to the second power, or 10 to the third power. What do we mean by numbers between 1 and 0? Well, you could be at like 1.2 would be an example, 5, or 8.76. All of those are examples of numbers between 1 and 10. So can you have a number like 0.7 or 1/2? No, you can't. You can't have 10.1. You can't even have 10. It's got to be less than 10. It's got to be greater than 1. All right? Greater than 1, less than 10. So not including 1. Well, sorry, not including 10. But I guess it does include 1. Create a number between, to convert from standard to scientific. So standard would be like a number like a million. To convert a number like a million to scientific notation, you would create a number between 1 and 10 by moving the decimal. Number 2, you count the number of times that you move the decimal. This will be your power of 10. If your number is greater than 1, the exponent will be positive plus. And if your number is less than 1, like a decimal, the exponent will be negative. Minus. Little minus sign. Yeah. All right. So complete the following problems. Let's go ahead and take a look. We want to convert this large number into scientific notation. Now, this is a pretty big number. It's not huge, but it's pretty big. So we want to take this number right here and turn it into a number between 1 and 10. This number right here. Turn it into a number between 1 and 10. And to do that, I take the decimal, which ordinarily would be right over here. That's where the decimal normally would be. And I want to move it inward so that's between a number between 1 and 10. Basically, I only want a single number in the ones place. Okay? I can't have a decimal here because that's bigger than 10, because that's 18. I can't have it right here. 185 is too big. But I can't have it right here. 1.85. I don't want it over here either because that's 0.185. Again, has to be bigger than 1. Has to be between 1 and 10. So decimal is originally at this point. I'm going to move it in. How many spaces? Well, let's see. 1, 2, 3, 4, 5, 6. I move it 6 places so that it drops right there. My new number is 1.85. and it's a product, so you're multiplying it by 10 to the what? 10 to the 1, 2, 3, 4, 5, 6. I moved 6 places, so it's going to be 1 times 10 to the 6th. Now, there is some confusingness, which is like, hey, how do you know it's like a positive 6 or a negative 6? Think of it this way. Big numbers mean positive exponent, positive power. All right, yeah, I know I didn't spell power right. Positive power. Big number means positive power. Like, this is a big number, which means the power should be positive. Small numbers mean negative power. All right, let's convert this one. We should have a decimal point right here. And so how many spaces does it take to get there? 1, 2, 3, 4. 4 spaces. So we have 4.2 times 10 to the, and we said 4 spaces, right? Again, is this a large number or a small number? It is a large number, so we are going to go with 4. So big numbers, positive power, small numbers, negative power. Now, what do we mean by small numbers? We mean numbers less than 1. So if you have like 0.005, that's a number less than 1. That's a small number. Or 0.500051, that's a small number, so you're going to have a negative exponent when you convert that to scientific notation. Anyways, let's go to number 3. Oh, hey, look at that. We are talking about small numbers, so we want to turn this into a number less than, or in between 1 and 10. So the decimal point would ultimately need to end up right over there, because 7.8 is definitely between 1 and 10. If you put it over there, it'd be like 78, which is too big. Over here would be too small, 0.7. So how many spaces did I move to get there? 1, 2, 3. 3 spaces. So I have 7.826 times 10 to the, and I moved 3 spaces. So I went small number means negative power. Negative power. So I'm at 3 spaces, 10 to the negative 3. Easy, right? Not too bad. Not too bad. All right, convert the number to scientific notation. Ooh, I have just the number 1. So between the number 1 and 10, it does not include 10, but it can include 1, so the decimal point wouldn't be right there. I would have 1 times 10 to the, how many spaces do I move? 1, 2, 3, 4, 5. 10 to the negative 5, because I turned into a small number. It's probably the easiest way to remember it. You can't, because if you start saying like, oh, if you move left, you do this. If you move right, it depends on how you count. So that rule has never really helped me all that much. Whereas big number, positive power, small number, negative power. All right, and let's take a look at converting to scientific notation to standard. So if we have a scientific notation number like this, how do you convert it to standard? Well, you are going to move the decimal the same number of places as the exponent. If the exponent is positive, move the decimal to the right in order to make that number bigger, larger, bigger. Add zeros as placeholders if necessary. Now, if the exponent is negative, move the decimal to the left. Sorry, that's an ugly left. In order to make the number smaller. Remember, negative exponents, you should have a small answer. Again, add 0 placeholders if necessary. So convert this number to standard notation. Take a look. Should we expect a large number or small number? Hint, hint, look at the 7. Is it positive? Ooh, it is. Therefore, we should probably expect a large number. Not some number with a bunch of decimal points and zeros, but like some big, big number. So let's convert it. What you would do is take this decimal point and move it to make it bigger. Now, if you don't remember which one goes right or left, if you want to make it bigger, obviously you're going to move your decimal this way. Because if you move your decimal this way, in the, 7 places, you're going to have to add zeros, and the decimal point ends up here, and you have a number like 0.00000783. And is that the kind of number you can expect from 10 to the 7th? I don't think so. So you're going to move the number, the decimal, in the other way, 7 places. So you're going to do 1, 2, 3, 4, 5, 6, 7. So we moved 2 places, and we had 5 more places to go. So guess what? We have to add how many zeros? Let's see. 2 places, we have to move 7 total. Well, how about 5 zeros, right? So 7, 8, 3, and then I have to move it 5 more places. So I have to add 5 more zeros, 3, 4, 5, and go ahead and add our commas. So this number is 78,300,000. Yep, that's it. Hooray, was that hard? I hope not. Let's try the next one. Convert this number to standard notation. Again, 10 to the 4th, that's positive, so we should expect our number to get bigger. 2.5, we're going to move it 1 space, and then 2, 3, 4, so 3 more spaces, which gives us 3 extra zeros. Whoops. Let's try that again. 2, 5, and then 3 more zeros. 25,000. Ta-da! That's not too bad. Let's try the negative numbers. All right, we have a negative number, so we should expect this number to get even smaller. How do we make it smaller? Well, we go in the opposite direction. We go left. So we go 1, and then we have to go 6 more places. 2, 3, 4, 5, 6. Now, you may have figured out, like, oh, if you move 1 place, and then you got to go, like, 6 total, then that's like 5 zeros. So you are correct. It's 1, 2, 3, 4, 5 zeros, then 8, 3, 4, 5. Yeah. So that's, and if you want, you can put that 0 up there also. It doesn't really matter. Number 8, convert this to standard notation. Again, decimal point starts here because, you know, with 3, you have an invisible decimal point there. You want to make this smaller, so you go 1 space and then 2 more. So add 2 zeros, 1, 2. And you write that 3, 1, 2, 3. And then that's it. That's your answer. All right, last question. We want to complete the missing blanks in the table below. This is standard. They want to make it scientific. So let's do this. We want a decimal right here. And if we have the decimal right there, we have 5.82. And then, let's see, how many spaces do we have to move? Oh yeah, it's going to be times 10 to the something. Let's see, how many spaces do we move to get there? 1, 2, 3, 4, 5, 6. Times 10 to the 6. So look at that, 5.82 times 10 to the 6 gets us a large number like that. All right, and this one right here, 4.25 times 10 to the 5th. Well, we should expect a large number, which means our decimal should move this way to get bigger. So it moves 2 places, and then it's going to move 3 more because it needs to get to 5. So 4, 2, 5, and then it needed to have 3 more spaces, so 3 more zeros. Let's do the next one. 1,200. They want us to put in scientific notation, which means the decimal should be right over there. So we should have 1.2 times 10 to the something. Let's see. And we want it to be, this is considered a large number. So how many spaces did we move to get to the normal place right over there? That's 3 spaces, so 10 to the 3rd. Next, we have 6.27 times 10 to the negative 7th. Ooh, negative exponent means very small number. How do we make a number smaller? Well, we just go this way too. So if we start off right here, we go 1 space, and then we need to go 7 total. So like 1, 2, 3, 4, 5, 6, 7. You have to add like 6 more zeros. So 1, 2, 3, 4, 5, 6, and then the 7, and then 2, 5, 7. Yay. All right, last number. This is a very small number, huh? So we should have a negative exponent. So our number should be 1.5 times 10 to this negative something. Negative what? 1, 2, 3. Negative 3. That's it. That's how you turn numbers from standard to scientific notation, or from scientific to standard notation. Go ahead and try some problems on your own.